This is part 3 in a series on solving quadratic equations in 4 different ways and showing that we'll get the same answer. For this video, we're going to be solving 0 equals 3x squared minus 4x plus 5. And we're going to start with factoring. And what we need to note first is that factoring does not always work. When it works, it is probably the fastest method, but it does not always work. I'm going to start by copying the equation down first. So we have 0 equals 3x squared minus 4x plus 5. And on this next line, we're trying to break this into two factors. In these first two slots, we want to multiply to get 3x squared. Because 3 is prime, our only option here is 3x times x. And then in these last two blanks, we're going to have a constant, and we want them to multiply to get 5. So off to the side, I'm going to write down my options would be 1 times 5 or -1 times -5. Okay, and while we want those two numbers to multiply to get 5, we also want this loop and this loop to add to -4x. Because we want them to add to be a negative, we are most likely going to be using the -1 and the -5 because there's no way to use positive numbers and get out a -4x. So to start, let's try a -1 here and a -5 here and check the loops. So this top loop would be -15x and our bottom loop would be -1x. When we combine them, we get -4x, and so this one is not correct. So let's try switching those. So we'll do -5 here and -1 here, and let's check the loops on this one. The top loop is 3x times -1, which is -3x. The bottom loop is -5 times x, which is -5x. Those combine to -8x, so this also does not work because 5 is prime. These are the only two options, and if I plugged in +1 and +5, there's no way I could combine to get -4x, so this one does not factor. That does not mean necessarily that this equation does not have a solution. It just means that this does not have a, um, yeah, it just doesn't factor. Doesn't have a real solution. Okay, so if we consider graphing, let's copy over our equation. 0 equals 3x squared minus, what did we say, 4x plus 5. I would highly suggest using a TI-84 calculator, especially on this equation, which we'll see soon. To start, we're gonna plug in x from -1 to or -2 to +2, and then whatever we get for y, we'll graph. I would, I'm going to be using my TI-84 table function to fill this out quickly, but if you don't have that, you can fill out a table like I'll show here. Okay, so I'm going to look at my table for this equation, and I'm pretending that this is a y equals instead of a 0 equals. When I do that, -2 gives me a 25. -1 gives me a 12, 0 gives me a 5, 1 gives me a 4, 2 gives me a 9. So let's graph that and just see what it looks like. The first two are off the grid, so we're going to start with 0, 5, and 1, 4, and 2, 9. So it's hard to tell what's really going on here, but we can kind of see that somewhere between um, 0, 5 and 2, 9, there is a curve. So it doesn't really matter, but we know it looks something like this. And if it looks something like this, and we're trying to find where the y is 0 because we plugged in y equals instead of 0 equals, we know that this graph is never going to cross the y-axis, so this one has no solution. I should say no real solution, I guess. So I'm going to say no real solution. We're going to get imaginary solutions. If you're in Algebra 1, you will not be doing the imaginary part, but I'm going to go ahead and find the imaginary solutions for those watching who are in Algebra 2 or college algebra. So this has no real solution. Okay, so let's go ahead and go to completing the square. This method always works. It is just very tedious. So we're going to start by rewriting the equation. I'm going to try to write small this time. 0 equals 3x squared minus 4x plus 5. And we're going to start by grouping these first two terms. On the next line, we're going to rewrite this, but with some space in our group. So this is going to be 3x squared minus 4x with some space. And then don't forget that plus 5. On this next line, we're going to factor out our leading coefficient. So I'm going to divide this pink parentheses by 3. So that brings my 3 on the outside. And on the inside, I'm left with x squared minus 4/3 x with some space. And then again, don't forget that plus 5. All right, now for the actual completing the square step, we have 0 equals 3. And this time we want to create a parentheses squared. We want to create that perfect square. And to do that, we've done it on a couple of easier videos, but we're going to divide 4/3 by 2. And when we do that, we get minus 2/3. And then to complete the square or fill in that blank, we square 2/3 and we get 4/9. Now to go back up to fill in this blank here, we're not just going to bring up the 4/9, but we have to bring up 4/9 times 3. Because if you notice, this parentheses has the 3 factored out, but this equation has the 3 factored out, but if we look back up to the top, this one has it factored back in. So we need to multiply by 3 to fill in this top spot. And then when we do that, 4/9 times 3 is 4/3. You can't just randomly add something to an equation. So since we added 4/3, we also need to subtract 4/3. And since I already wrote 5 on the next line, I'm going to write minus 4/3 on this line as well. But then at the bottom here, I'm going to use my calculator to actually do 5 minus 4/3. And when I do that, I get positive 11/3. Okay, now that I've completed the square, I'm trying to solve for x, so I'll start with subtracting 11/3. And I get a negative 11/3 equals 3 times x minus 2/3 squared. Next, I'm going to divide by 3 on both sides. And when I do that, I have a negative 11/9 equals x minus 2/3 squared. Next, I'm going to square root both sides. And this is where, if you were in Algebra 1, you would stop and say no real solution because you cannot square root a negative. But I'm going to continue on for those in Algebra 2. Okay, so when we square root, we have negative 1 times 11/9. I'm going to be breaking this down, equals x minus 2/3. And on the left, when I bring out this 9 and this negative 1, I have I/3 times the square root of 11. And you can write that a couple different ways, I guess. Let me see. To write it a little bit cleaner, I might I/11/3, like that, equals x minus 2/3. I'm going to add 2/3 to both sides. Oh, sorry, this would be plus or minus. Plus 2/3 on both sides. And I have 2/3 plus or minus I square root 11/3 equals x. X is by itself, this is perfectly fine. Since they both have 3's on the bottom, I'm going to write this a little cleaner by writing 2 plus or minus I square root 11 all over 3 equals x. So this is the first time we're actually seeing this solution. We were not able to factor because we're going to have an I and a square root in the answer. We were not able to graph and get the imaginary solutions. Graphing is sufficient for algebra 1. But now we're going to do the quadratic formula and we will get the same answer on the quadratic formula. So let's start by writing that out. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to bring down our formula. 0 equals 3x squared minus 4x plus 5, and we're going to label our a, which is with x squared, our b, which is with x, and our c, which is our constant. I always like to start with this underneath part called the discriminant. So I'm going to start with b squared minus 4ac. When I do that, I'm going to have negative 4 squared minus 4 times 3 times 5. And I'm going to use my calculator so I don't mess up on the arithmetic. So negative 4 squared times minus 4 times 3 times 5, I get negative 44. Highlighting this in green to show you we are going to plug it in under the square root here. So we're going to have x equals, we'll zoom out a little bit, negative b for us is going to be positive 4 plus or minus the square root of negative 44 over 2 times a is going to be 6. Now we first need to simplify that negative 44, and it's going to be negative 1 times 4 times 11. We chose 4 times 11 because 4 is a perfect square. Now when we continue to simplify, we can take out this negative 1 and the 4. When we do that, we have 4 plus or minus 2i square root 11 all over 6. This is probably fine, but just to be safe, we want to simplify this because 4, 2, and 6 can all divide by 2. So the best answer is x equals 2 plus or minus I square root 11 all over 3, which is the same answer that we got by completing the square. So for this equation, we could not factor. We graphed, but it wasn't super helpful. If we were in algebra 2, if we were in algebra 1, it was more than fine. But then by completing the square and by doing the quadratic formula, we were able to solve the equation. I did want to say if you were in algebra 1 and you saw this immediately, you could stop and say no real solution because we have a negative going underneath a square root.